Hi everyone, welcome to this lecture. In this lecture, you will see an overview of the project that you will be developing throughout the course. I will also make an introduction to event-driven architecture, focusing on the advantages and the use cases. In addition to that, I will explain how event-driven architecture can be used in a microservices environment. Here is the big picture and the architecture of our application that you will be developing in this course. As you see in this picture, at the end of the course, you will have an application that composed of multiple microservices and components. Before going into the details of each microservice, to give you some context, let's focus on what this distributed application will do. In real-life applications, you will have a source of data that you can store in different forms, such as on flat files, on a relational database like PostgreSQL, or on a query engine like Elasticsearch. Each data store will hold the data in different formats and serve for different purposes. If you have a streaming of data, you may even decide to hold your data in an event store, such as Kafka, in the form of events. Then you can create event-driven consumer microservices to get the data from your event source and use or transfer it from different purposes. For example, you can stream data from a Kafka topic using Kafka Streams, then run some calculations on it, and then put your calculated data again into Kafka using another Kafka topic. Another example is you can consume the data from Kafka and put on a relational database such as PostgreSQL to run some analytics calculations or just create your data warehouse. Another example, you can consume the data and send to a query engine such as Elasticsearch to make it easily searchable for your clients. Because Elasticsearch is designed to enable querying faster with effective algorithms. In this course, you will carry out all these examples. You will first start streaming data from Twitter using a microservice and put the data on a Kafka topic. And build an event-driven architecture using Kafka as the event source and write your microservices around Kafka. So to demonstrate event-driven architecture, I will develop multiple event-driven microservices by reading the data from Kafka. An event-driven microservice will simply subscribe to a Kafka topic and consume the data that comes into Kafka in real time. The event-driven services that you will develop will do different jobs. The next microservice will consume the tweets from Kafka and put on Elasticsearch to make the data searchable effectively. This will actually allow the implementation of CQRS pattern using Kafka and Elasticsearch. Another microservice will consume the tweets from Kafka, do some analytics calculations with the data, and put on PostgreSQL relational database. This data will later be fetched from the query service to show the analytics results to a client. Then another service will consume the data from Kafka and create a Kafka stream to run some calculations in memory and create a searchable in-memory store. Again, this data also will be fetched from query service that you will develop later to show the calculation results to a client. Then you will complete the query component of CQRS pattern with a new microservice, query service. This service will query the data from Elasticsearch, and remember that Elasticsearch is populated with Kafka to Elastic service in this architecture. This query service will show the results from Elasticsearch, and in addition to that, it will get some analytics data from Kafka Stream service and analytics service by making a REST call. So in this section, you will have a chance to see how REST codes work between microservices as opposed to event-driven approach that you were developing. To make the search component more beautiful, you will then add a web client as a separate microservice. This web client will use a front end using Bootstrap and TimeLeaf to query the data from query service. To easily organize and manage these multiple microservices, you will also implement and run config server, API gateway, and discovery service as separate services. And to secure the communication between services, you will use KeyCloak authorization server and implement OAuth 2 and OpenID Connect protocols. We will go into the details of each of these components during the course. Finally, you will add monitoring, tracing, and log aggregation to your microservices using the right tools. In the next lecture, I will give more details about each of those components and microservices. So, to start building this architecture, you will need a source of data. And as I mentioned in this course, I chose Twitter as the source of data, as you see on the very left of the picture. Basically, you will read tweets from Twitter in the form of events and store these tweets in Kafka. So you will be using Kafka as the event store in this application. To stream tweets, you will use a Java API from Twitter4j library, and you will provide any keywords that you want to search the tweets from Twitter. So why did I choose Twitter as the source data? I used Twitter data just to provide some input data to the application. It could also be any other source. I can even create some dummy streaming data, and actually, you will find a mock streaming data lecture which I have added to this course in case you have some difficulty getting a Twitter developer account, because Twitter requires to create an account to allow using its API. In this course, you will use event sourcing and have event-driven microservices. That means the services will talk to each other using events that are created on Kafka. Event sourcing is a style of application design where state changes are logged as a time-ordered sequence of records. Kafka supports very large stored log data, and it makes Kafka a perfect backend for an application built in this style. With truly decoupled services, event-driven architecture is a perfect match for reliable, fault-tolerant, and better scalable microservices architecture by solving the issues raised, like communication of services and API changes. Events can be any real-time change data, such as signals created by sensors, dropped packets on networks, security violations on file systems, or creating tweets on Twitter. Event-driven architecture can be used in all types of applications that can be pictured using events. As you can imagine, not all systems can completely fit into an event-driven, asynchronous, and eventual consistent architecture. In that case, event-driven system can be combined with a synchronous solution like REST calls in case there is a need to do an operation with traditional consistency manner following ACID transactions. To store the events, I chose Kafka in this course, as I mentioned, because Kafka works really well with stream of data, and actually, that was another reason of choosing Twitter streaming as the source of data. Kafka holds the events in immutable formats and provides fast, resilient, and scalable solution. If you have a big amount of data, and if especially you are streaming data infinitely, as in the Twitter streaming, Kafka will provide a faster and resilient solution when compared with other solutions like RabbitMQ. Because Kafka is designed for holding and distributing large volumes of messages, and it can easily scale using the partitioning in the topics, which is the data structure in Kafka that holds the data. On the other hand, for example, RabbitMQ is mostly designed for vertical scaling, that is, adding more power, and doesn't have a natural scaling structure as Kafka has. Kafka also provides a resilient system thanks to the replication factor. That means it replicates the data on different nodes and on different partitions so that the data will not be lost even though there is an issue with one of the nodes or partitions. We will talk about the advantages of Kafka in more detail during the course. The main purpose of using event-driven services is to decouple them. So instead of calling the service directly, we use Kafka in between and make the communication asynchronous. That is a good fit for microservices in case we can tolerate asynchronous communication. This way, when a target service is down, it will not affect the caller service because of the decoupling. We just get the data a bit later, but we will never block the caller service. Traditionally, to share data, REST calls can be used. You will also see a REST communication example in this course, from query service to analytics and Kafka Stream service, as I mentioned. However, a REST call will be a synchronous operation because REST uses HTTP to communicate, and HTTP is a synchronous protocol which requires to send a request and wait for a response immediately, blocking the caller. As you can imagine, with multiple services communicating over the network, this would cause significant problems. There can be delays causing higher response times, and if there is no timeout applied properly on the caller service, that can even block indefinitely. The main problem resides in the REST communication is the strong coupling of different services. So using event-driven architecture, you can truly decouple the services, create resilient services, easily perform asynchronous communication of services, handle transactions that span multiple services, and scale better by removing the state from services and holding them on an event store. Great! After discussing the use cases that you will be applying during the course, let's go into the details of each microservice and component in the next lecture. So I will see you in the next lecture.